from Oxford, Ohio, and welcome to the Department of Geology and Environmental Earth Science. I'm Dr. Claire McLeod, and one of the most exciting components of my role here at Miami is working with you, students, on research questions that address the evolution of the rocky planets in our solar system, including our own Earth, but also that of Earth's moon. How can we use the rock and mineral record to investigate and tell the story of Earth's evolution and the evolution of the rocky objects in our solar system? And what does that look like from the student's perspective?
Hi, my name is Shalene, and my favorite aspect of studying lunar meteorites is the supportive environment that the university provides to work together to explore the unknown.
The faculty here in the department are committed to working collaboratively with students to support not only their STEM professional development, but also to engage in their scientific curiosity with respect to questions that we have as scientists regarding the geological evolution of our planet and those rocky objects around us. Opportunities exist for students to travel, to go into the field and collect samples pertaining to some of these research questions. In my lab in particular, research questions are focused on utilizing igneous rocks, rocks which crystallize from magma, and then using the minerals and textures preserved in those igneous rocks to trace volcanic processes operating on planetary objects. Here on Earth, it's a little bit easier to travel to our field site. And so students gain field-based skills. They are trained on how to develop skill sets as a scientist in the field, collect sampling methods using correct scientific protocols, observe and collect data, and how to best prepare those samples for analysis back here at Miami. Whilst in the field, students gain hands-on experience with a wide variety of instruments, preparing them for a successful career post-graduation. And of course, we always try to have a lot of fun whilst we're out there collecting our samples. But back here at Miami, what does studying those samples look like? It looks like, in my lab, taking those samples and studying the rocks, their components, and their minerals at the micro scale. And this involves a lot of hands-on training with, again, a variety of numerous instruments. When we get down to the micron scale, the geological record of planetary objects gets incredibly fascinating. You can think of these rocks and minerals at the micron and sometimes nanoscale as time capsules of planets' histories. How do we go about interpreting these, and what do the results mean in terms of planetary evolution? These are the types of questions that I work with students here at Miami to answer. So it's thanks to collaboration with students that we can start to address some of these long-standing questions regarding planetary evolution. And as a result, students get the opportunity to communicate and present these results in a variety of different formats.
Hi, I'm Jared, and I study lunar meteorites. One of the cool things about being at Miami, other than studying moon rocks, is the amount of awesome support I get from advisors and peers.
As part of supporting our students' professional development, our students get the opportunity to disseminate their information to a wide variety of audiences, and through this gain valuable skills in networking, in addition to gaining insights into the types of professional development opportunities through research that exist within our field. Again, numerous opportunities exist for students to work collaboratively with faculty in our department. In my lab, opportunities for undergraduates include studying Apollo samples, lunar meteorites, and a variety of different rock types from across our own planet to investigate how volcanic processes are recorded in the rock record and what those micron scale observations can tell us about processes operating throughout geological time and on the kilometer scale. Thank you for listening. Best of luck in your decision to pursue undergraduate level education. If anything I discussed today has got you excited about what we can do with rocks and minerals on our planet, but also other planets, my email address and website are listed there. My personal Twitter account is also posted there if you want to follow along and see all the wonderful, exciting things that are happening in the field of planetary science. And I've also posted the Twitter handle for our department. So I encourage you to follow along and see what we get up to as a department.